Hello guys, welcome to Hvac solutions. In this video, I am going to show you how to do Hvac heat load calculation by using E20 sheet. So this is the E20 sheet. This is our school building plan located at Bangalore location. For this room, this classroom G15, today we are going to do heat load calculation. Okay. Here length and width of the room is 20 by 30 feet, means 19.91, you can take 20, not an issue. Here 30.01, you can take 30. So length and width is 20 by 30, means 600 feet area, square feet. And we have two glasses 5.9 by 4 feet, you can take 6 by 4. This also you can take 5.9 by 4 is there, you can take 6 by 4 feet, means here 24 feet, here 24 feet. Total glass is 48 square feet. And false ceiling height is 10 feet, medium weight of the building is 80 lb per square feet. Okay. See here, you have to project school building. Our class is G15, length 20 feet, width 30 feet. You will get the area 600 square feet. Okay. False ceiling height is 10 feet. You will get automatically value. Volume is 6000 cubic feet. Okay guys. And this latitude, altitude, daily range, outside air, these all values you will get from design data book, that I will show you. So these are the outside design condition for Indian cities. Our location is in Bangalore. See here, Bangalore. Latitude is 12.6, daily range is 22, altitude is 921. For school building, we have to take these values: dry bulb 93.2 and wet bulb 67.3. Please note it down guys. See here, latitude 12.6, altitude 921, daily range 22. And outside condition is here 93.2, wet bulb 67.3. Now I will show you psychometric chart. See, our dry bulb temperature is 93.2, wet bulb 67.3, and altitude you have to put 921 for Bangalore. If you put the value, you will get immediate output values. I will show you. Suppose 300. Sorry, 1 second. Yeah, 93.2. So here we got relative humidity 26.4, you can take 27, and humidity ratio 63.6, you can take 64. Okay. See, relative humidity is 67 and humidity ratio is 64 from psychometric chart. And inside room we have to keep temperature constant, dry bulb 75 and relative humidity is 50. And wet bulb and humidity ratio we can get from psychometric calculator. Our dry bulb is 75 and relative humidity is 50. So you will get these values. Humidity ratio is 64.65. You can take 65. And wet pulp is 62.43. You can take 63. Okay, 65, 63. Difference you will get this value 93.2 minus 75, 18.2. Okay, these are the value you will get. 64 minus 5, 64 minus 65 minus 1. Okay. So, and next is solar gain through glass. See, we have two glasses exposed to sun in the south direction, each glass of 24 feet. So we have two glass, so 48 feet. Our wall is exposed to sun in south direction, south, and square feet is 48. And solar gain I will show by data book. This is the solar heat gain through ordinary glass. Here 0° north latitude is there. Our Bangalore location latitude is 12.6. Here 12.6 is not there, so 10 is there and 20 is there. We have to go for higher value. In this 20° north latitude, we have to take the highest month, summer, means July and May. Here our wall is exposed to sun in south direction. Okay, so here south we have to take higher value is 14. So solar gain 2 glass is 14 and solar factor is constant 0.78. If you multiply you will get this value 524.16. Okay. Next is outside egg. Here you will get automatically value this 600, and in our classroom total 57 people are there, so 57, and CFM per square feet and CFM per person you will get from data book. See here, minimum ventilation rates in breathing zone. Our location is classroom. Students age are between 5 to 8. So for classroom we have to take this value. CFM per person is 10 and CFM per feet square is 0.12. Okay. CFM per person is 10 and CFM per feet square is 0.12. CFM per person is 10 and CFM per square feet is 0.12. If you multiply all these values you will get this value. So you will get 642 CFM. Okay guys. So outside air is finished. Next is transmission gain through wall and roof. So our wall is exposed to sun in the south direction. So this is the our room, classroom G15. So we are doing calculation for this wall. Okay. So here the length is 30. So you have to multiply with 2 height, that is 13. False ceiling height is 13 feet and 2 height is So false ceiling height is 10 feet and true height is 13 feet, 3 feet extra. So 30 into 13, you will get 390. 390 minus, we have to subtract the glass area, that is 48. 390 minus 48, 342 you will get. Okay. Next is equivalent temperature difference. This is the equivalent temperature difference. See, our building weight is 80 lb per square feet and our wall is exposed to sun in the south direction. Okay, here south. Here we don't have a 80, our building weight is 80, here we don't have a 80, so we have to take average from 60 and 100. So 60, in 60 highest value is 26, below that only you have to take for 100. 26 plus 16, 52. Sorry, 26 plus 16 you will get 42 divided by 2. So you will get equivalent temperature difference is 21. Suppose if our building weight is 60, you can take directly value 26. Okay, our building weight is 80, we don't have a value 80 here, so we will take average from these two values. So here 26 plus 16, 42 divided by 2, 21. For this we have to add correction factor. Our temperature difference is outside and inside temperature difference is 18.2. So here 18.2 is not there. We have to go for higher value, that is 20. And daily range for Bangalore is 22. We have to intersect the value. Here 20 and 22. You will get 4. So correction factor is 4. ETD 21, we have to add correction factor 4. Means 21 plus 4. You will get 25. Okay. So here 25. Next is U values. Actually U value you will get from civil people. If you will not get from civil people, you can use the U values as per standards. I will show you. Guys, please note down. For external wall, U value is 0.089. For roof, 0.063 U value. For partition, U value is 0.487. For typical floors, U value is 0.358. Or you can take 0.36, not an issue. So here, for external wall, 0.089 U value. If you multiply all these things, 3, you will get 760.95. Okay. Transmission gain through walls and roof is finished. Next is infiltration. You will get automatically value here 6000 cubic feet, and here our wall is exposed to sun in only one direction. So air exchange per hour ACH is 0.25. You have to take ACH value, you have to take 0.25. If wall is exposed to sun in the two direction, you have to take value 0.5. We have only one wall is exposed to sun, so it is 0.25. So air exchange per hour is 0.25. If you multiply, you will get this value. Okay. So infiltration you got 25, net outside air, nothing but bypass outside air is 617. Okay guys. So infiltration is finished. So next is transmission gain through other. All classes you will get automatically from here 48 square feet, and temperature difference is 18.2, and U value you have to take from data book. See here, typical fenestration characteristics. Our glass is fixed. and made up of material aluminum. So we had to take U value here. U value for the glass is 1.13. Okay. Here fixed and aluminum. U value is 1.13. So U value is 1.13. If you multiply, you will get this value. We don't have a non-AC partition glass. Leave it as it is. Next is non-AC partitions. See, this area we already calculated. Okay. This area having AC, this area also having AC. This area is a non-AC. So we are calculating for non-AC partition, right? So this area is non-AC. So this length is 30 feet. So 30 into 2 height, that is 13. So 30 into 13, 380. So non-AC partition is 380 feet, square feet. 390 square feet. Okay. And non-AC floor, ours is ground floor below that non-AC area, so it is considered as non-AC floor, that is 600. And temperature difference is 18.2. In this 18.2, you have to separate -5 for each these rows: non-AC partition, non-AC partition glass, non-AC partition, or non-AC floors. Okay. 18.2 minus 5, 13.2, 18.2 minus 5, 13.2, like that. Suppose if I put 20, we'll get 15. Okay. If you put 10, 5 difference. So ours is 18 point. Okay. And U value, this finish, if you multiply, you will get this value. And for non-AC partitions and non-AC flow, just now show you, you will get from civil people. If you not get from the civil people, you have to follow standard. So U value for non-AC partition 0.48, U value for non-AC flow 0.36. Okay. If you multiply, you will get these values. So transmission gain through other is finished. Next is infiltration and outside air. Guys, you will get this value automatically. Infiltration is 25 and bypass outside air is 17. No need to put anything, you will get automatically. Okay. This balance factor, this temperature difference 0.1, this conversion factor 1.08, 1.08. Okay. If you multiply, you will get these values. And next is people. Here we have 57 people are there. Numbers of people 57. Okay. And BTU, this we have to take from data book. 1 second. Guys, please note down. Heat gain from people. Here ours is classroom. Here classroom is not there. You have to take from this value. Office, hotel, apartments. Sensible heat is 245 and latent heat is 155. Okay. So here sensible heat is 245, and for light you have to refer lighting power density. Ours is classroom, so here lighting power density is watt per feet square is 1.4. You have to multiply with our total room area, 1.4 into our total room area is 600. If you multiply 1.4 into 600, you will get 840. Okay. Next is appliances. You will get from electrical department. If you not get from electrical department, approximately you can take 1000 watts for appliances for in the classroom. For people, for 57 children are there. Okay. Next is miscellaneous. We don't have miscellaneous. Leave it as it is. And here sorry guys, and here this is the B2 power hour, B2 per hour sensible rate finish 245. And next is this ballistic factor, it remains constant. This usage factor, this also constant, this also constant. This conversion factor 3.41, 3.41. Okay. If you multiply, you will get these values. So total room sensible heat is 29401.693. Okay. And next is latent heat. Here people, so we have 57 people are there. Infiltration 25 you will get automatically, and bypassed outside air is 617. See here infiltration and bypass outside air. And here I shown you from the design data book, HVAC data book. It is latent, for latent heat it is 155 B2 per hour. One second, I will show you. See here heat gain from people, latent heat is 155. Okay. And here humidity ratio difference -1, and conversion factor 0.68, here 0.68, this balancing factor 0.1. Okay. If you multiply, you will get these values. So total room latent heat is 8776.044. Okay. And safety factor is 614.32308. You will get automatically, guys. And effective room latent heat is 9390.36708. Effective room total heat is 641,732.2296. Next is outside air heat. Here sensibility latent heat. Our total CFM is sensibility also 617. This also 617. And temperature difference is 18.2, and humidity ratio difference is -1. And conversion factor 1.08, here 0.68 for latent heat. So this 1 minus balancing factor, so you will get 0.9. If you multiply, you will get all these values. So total outside heat is 10,537.3728. And safety factor, you have to multiply 0.05 into this total outside heat, you will get this value. Okay. and effective outside heat is, if we add these two values, you will get this value 110064.2414, and grand total heat is 5279.796.471. Okay, means effective total heat and effective outside heat. If we add these two values, you will get this value. Okay, and ton of refrigeration is 4.3997 ton. You have to divide this value by 12,000 because we need in ton. Okay, 1 BTU is 12,000 ton refrigerant. For that reason, you have to multiply by 12,000. 1 BTU is 12,000 ton refrigeration. For that reason, you have to multiply by 12,000. So this divided by 12,000, you get this value. So ton of refrigeration is 4.3997. Now 4.4 ton. Okay. Next is effective sensible heat and ADP, apparatus dew point. Effective sensible heat is, you will get automatically effective sensible heat factor equal to effective sensible heat divided by effective total heat. Effective sensible heat and effective total heat. So we'll get this value. So with the help of effective sensible heat factor, you have to select ADP, apparatus dew point. Our effective sensible heat factor is 0.77. Here, this is the apparatus dew point. So our dry bulb temperature is 75 and relative humidity is 50. Here we have to check for ESHF, effective sensible heat factor. Our effective sensible heat factor is 0.77. So 0.77 is not there. We have to go for higher value, 0.78. For 0.78, apparatus dew point, that is ADP is 50. So ADP is 50. Okay. And dehumidification area is 22.5. Dehumidified air quantity is 1330.94 CFM. Okay. So guys, this completes our HVAC heat load calculation for the room G15 by using E20 sheet, guys. Okay. If you like the video, please share and subscribe the video, guys. Okay. Thank you, guys.